Hey guys, so this is lesson number 4. Today we're talking about compound angle formulas, specifically the difference formulas. So there was a couple videos that Miss Bradley sent to me, and they covered our compound addition formulas, looking at sine of a plus b and cos of a plus b. So check out those videos, they're linked in the schedule. They talk about how we come up with these equations, these identities, but we're going to come up with the formulas now for sine of a minus b and cos of a minus b, and then look at tan as well. So sine of a minus b, well, we have this formula for sine of a plus b, so this is really sine of a plus a negative b. So sine of a plus negative b, that we're just going to take this part of the equation, and every time we have a b, we get a negative b. Plus cos of a sine of negative b. And we can think back of our lesson number 1 and 2, cos of negative b. That is the same as cos of positive b. If we're going below and we have an angle this way, well, cos is positive in that quadrant. So cos of negative b is the same as cos of b. Sine of negative b is negative sine of b. And we can rewrite this with the negative in the middle. And we get sine of a minus b equals sine of a cos b minus cos of a sine b. So sine of a plus b, we get a plus in the middle. Sine of a minus b, we get a minus sign in the middle. We'll do the same thing and we'll look at cos of a minus b, which is really cos of a plus a negative b. So if we use our formula from lesson number 3, cos of a times cos of negative b minus sine of a times sine of negative b. Well, again, that cos of negative b, that's still just the same as cos of positive b. And sine of negative b is negative sine b. So we can bring out that negative sign. Negative, negative, we get a positive sine a sine b. So cos of a minus b is cos a cos b plus sine a sine b. For our addition formula, we had the same terms, cos a cos b sine a sine b, but for cos the sign was opposite. Cos a plus b, we get a negative. Cos a minus b, we get a positive here. Look at a couple examples using these. These are 2 more trig identities that are going to become useful, 2 more trig formulas. So let's look at cos of pi over 12. So cos of pi over 12, we don't know. Pi over 12 is 15 degrees. That's not one of our special triangles. We don't know off the top of our head. what cos of pi over 12 is. We could put it in a calculator, but we're going to get a decimal. But we want an exact value here. What we can do is now we can use our difference formula. Pi over 12, that is 4 pi over 12 minus 3 pi over 12. Or if we simplify those fractions, pi over 3 minus pi over 4. Cos of pi over 12, same as cos of pi over 3 minus pi over 4. Now we're going to use our formula. So our A is pi over 3, cos of pi over 3, cos of our B is pi over 4. Remember, we're subtracting B, so we're taking the positive value here, plus sine of pi over 3, sine of pi over 4. So now, pi over 3, pi over 4, those come from our special triangles. These are all values that we know or should know. If you have some questions about what these, if you're not sure off the top of your head what these will equal, go back to our last unit on trigonometric functions and make sure you review the special triangles. But cos of pi over 3, that is 1 over 2. Cos of pi over 4 is 1 over root 2. Sine of pi over 3, that was square root of 3 over 2. And pi over 4, sine of that is 1 over root 2 again. We can multiply out our brackets. So half times 1 over root 2, we get 1 over 2 root 2. Plus root 3 times 1 is root 3. 2 times root 2 is 2 root 2. So this equals 1 plus root 3 over 2 root 2. That is cos of pi over 12. This is our exact answer. We don't need to find what the decimal approximation is. This is as exact as we can make it. We can't add 1 plus root 3, of course. So this is completely okay as a final answer. If you're asked for an exact value, this is what you're expected to give. B, sine of pi over 12. So same thing, pi over 12. That's just going to be, as we did up here, pi over 3 minus pi over 4. So we're going to plug that into our sine A minus B formula. So sine of pi over 3, cos B, so cos pi over 4, minus cos A sine B. Sine of pi over 3, that was root 3 over 2. Cos of pi over 4 was 1 over root 2. Cos of pi over 3 was 1 over 2. And 1 over root 2 again. Multiply it out, we get root 3 over 2 root 2 minus 1 over 2 root 2. So sine of pi over 12 is going to equal root 3 minus 1 over 2 root 2. Again, that is our exact answer. If you're asked for an approximate answer, we can just put that all, we can just plug this into our calculator, but this would be our exact answer. Last but not, well, I don't know, we have a couple more examples. C, we're going to look at how this helps us talk about this identity that we've already discussed, our cofunction identity. So cos of pi over 2 minus some angle theta. We don't know what theta is, but we can use that formula that cos A, cos B plus sine A, sine B, cos of pi over 2, or back in degrees, cos of 90, that's 0. So 0 times cos of theta, plus sine of pi over 2, sine of 90 was 1 times sine of theta. This just equals 0. 1 times sine theta is just sine theta. And that gives us this cofunction identity we already have discussed. Cos of pi over 2 minus theta equals sine theta. There's a couple simplifications that we can make. So simplify the following expression. So let's call this d sine pi plus x plus sine pi minus x. So we're looking at some angle pi plus x, sine of this angle, or sorry, x my mistake. This is sine of pi plus x to here, sine of pi minus x. We're looking at these two sines being added together. Let's see what happens with our function. So sine A cos B plus sine B cos A. So that's from our first sine. Second one, we get sine of A cos B minus sine of B cos A. And because it's all being added together, we can really drop the brackets. Sine pi cos x, sine pi cos x. We get two of those. Sine x cos pi minus sine x cos pi, those cancel out. And sine pi, sine of 180, is just 0. So 2 times 0 times cos x, that all equals 0. So if we're adding together sine of pi plus x plus sine of pi minus x, that's just going to equal 0. We have one more simplification example. Cos of x plus pi over 3 minus sine of x plus pi over 6. We have a cos A plus B. Cos A cos B minus sine A sine B. All of that is being subtracted by a sine A cos B plus sine B cos A cos of pi over 3 was 1/2. Sine of pi over 3 was root 3 over 2 minus sine x cos pi over 6 is root 3 over 2. And again, we're subtracting cos pi over 6 is 1/2 times cos x. So 1/2 cos x minus 1/2 cos x cancels out. We have two of these terms that are both negative, so minus 2 times sine x times root 3 over 2. 2 times root 3 over 2, well, that's just root 3. So we get minus, don't need the brackets. Brackets were just shown as a separate multiplication. Minus root 3 sine x would be our final simplification. We'll look quickly at what our tan compound tan compound angle formula would look like for both the addition and the difference formulas. So tan of a plus b. Remember, tan is just sine over cos. So sine of a plus b over cos of a plus b. This is going to get a little messy here, but sine of a plus b is sine a cos b plus sine b cos a over cos a cos b minus sine a sine b. We're going to multiply, or really we're going to divide everything by cos a cos b. So we're multiplying the top by 1 over cos a cos b, and we're going to multiply the denominator by 1 over cos a cos b. So that gives us sine a cos b over cos a cos b for that first term, plus this sine b cos a. We're also multiplying that by 1 over cos a cos b, so this gets divided by cos a cos b. That's our numerator, and our denominator, same thing. Everything's being divided by cos a cos b minus sine a sine b over cos a cos b. So our first term here, cos b cancels out. We get sine a over cos a. That equals tan a. Cos a cancel out. Sine b divided by cos b equals tan b. Cos a cancel out. Cos b cancels out. So this whole thing equals 1. Then here nothing cancels out, but sine a divided by cos a is tan a. Sine b divided by cos b is tan b. So tan a plus b equals tan a plus tan b over 1 minus tan a tan b. That is as simple as that gets. Kind of a mouthful, but we will use that in an example shortly. Let's also look at how we can do tan a minus b. So tan a minus b, well, that's tan a plus negative b, just as we did with our sine and cosine. That way we don't have to go through that whole process again of seeing what sine a minus b over cos a minus b is. We already have a tan formula, so we might as well use it. So our formula was tan a plus tan b, so we get tan of negative b here, over 1 minus tan a tan minus b. So tan was an odd function. For an odd function, tan of negative b is equal to negative tan b. Oh, we forgot an a here. Tan of a minus tan of b over 1. This, again, is going to become negative tan b, so we're going to end up with a plus here. 1 plus tan a tan b. Tan of a minus b is going to equal, let's try this again. 1 plus tan a tan b. Going to equal this here. So it's the exact same as our tan a plus b formula. Our signs are just switched. Look at 2 examples here. So tan of pi over 12, we already did sine of pi over 12 and cos of pi over 12. So if you remember from those previous examples, pi over 12 is pi over 3 minus pi over 4. We're going to use our tan a minus b formula. Tan of a is pi over 3 minus tan of b, pi over 4, all over 1 plus tan of pi over 3 times tan of b, pi over 4. Tan of pi over 3, that's just the square root of 3. Tan of pi over 4 is 1 over 1 plus, again, this is the square root of 3, tan pi over 3, times tan pi over 4 is just 1. So root 3 minus 1 over 1 plus the square root of 3. This is an exact answer, and we can even simplify a little more. If I multiply the bottom by 1 over root 3, and I multiply the top by 1 minus root 3, I'm really just multiplying by 1. Here I have a difference of squares. 1 plus root 3 times 1 minus root 3. So we get 1 squared minus root 3 squared is just 3. Root 3 times 1 is root 3. Minus 1 times 1 is negative 1. Root 3 times negative root 3 is negative 3. Negative 1 times negative root 3 is positive root 3. So we get 2 root 3 minus 4 over negative 2, which can be, we divide everything by negative 2 and rearrange, we get 2 minus root 3. So this is okay here. We can write it a little simpler, but I just want to show that you can do this. If you're doing more heavy math in university, you will use these tricks to kind of get simpler answers, but for now this is okay. I'm mostly worried about, can you use these sine, cos, and tan compound formulas? One more. Tan of negative 7 pi over 12 that's the same as negative 3 pi over 12 minus 4 pi over 12. I'm going to do this slightly different than the example. So that's tan of negative pi over 4 minus pi over 3. So tan of a, tan of negative pi over 4 minus tan of b, tan of pi over 3, all over 1 plus tan of negative pi over 4, tan of pi over 3. You might be wondering why one of these is negative and one of them is not. Well, our whole a is negative here, minus b is the formula I use. So our a is negative, our b is the positive, and I just use the a minus b formula. Again, tan of a negative is negative of tan of the positive. Tan of pi over 4 was 1, so this is just going to be negative 1 minus root 3 over 1 plus negative 1 times root 3. So we get negative 1 minus root 3 over 1 minus root 3. Again, that's okay. I'll show you one more example of how we can simplify it. We can multiply by 1 plus root 3. Multiply by 1 plus root 3. Again, this is a difference of squares. So we're going to get 1 minus 3 in our numerator. In the denominator, or sorry, in the denominator, in the numerator, negative 1 times 1, negative 1, negative root 3. Negative root 3 times 1 is negative root 3. Negative root 3 times positive root 3 is negative 3. So we get negative 4 minus 2 root 3 over negative 2. Divide everything by negative 2, and we just get 2 plus root 3. That's the end of that lesson. Right now, you just want to be comfortable being able to plug numbers into these formulas. We're going to look at how we can actually use these to simplify and prove certain equations and identities, but we'll get there in a couple lessons. For now, just make sure you're starting to think about things in terms of radians and becoming comfortable with those concepts. You're remembering your special triangle angles and other special angles that pop up over and over, sine pi over 2. But hope everyone enjoyed the assembly today. I recorded this right after it. For now, have a good day, and you'll hear from me in the next lesson. Goodbye.